Hello everyone, good evening. Welcome to AS Online. Today we are going to see a important revision for total machines for the TS Genco point of view and some important model of questions from each topic we will see. And here today we are going to see mainly, I will give total all the topics briefly once because it will take actually so much time to cover total machines, but in a short span. So whatever important points will be there in each topic in each particular part of machines again, like transformer, induction, DC and synchronous. So in each one we will see some important points. Okay. So orally I will give what points we need to focus in each topic of the machines. First we will start with transformers. Now in transformers, how many marks we can expect for TS Genco is not only transformer, it may be induction or DC or synchronous. Everywhere we can expect around 2 to 3 questions. 2 to 3 questions we can expect from each topic of the machines. Okay, from 4 parts of the machine. Now first, in construction of transformer, what we need to focus? Construction. Construction mainly we have 2 parts, transformer core and transformer winding. And here important is core material and how we laminated core we use, and what type of material we use, silicon steel or CRGO steel. What is the difference between these two, silicon, CRGO? What is main difference in silicon and CRGO? In silicon steel, the grains of the material are non-oriented, but in CRGO steel, the grains are oriented steel. Okay, that is difference. Which one will have least reluctance? Silicon steel or CRGO steel? No doubt CRGO steel will have very low reluctance when compared to normal silicon steel, because in CRGO grains oriented, no, reluctance will further reduce when compared to normal silicon steel, right? Next, in the transformer core, we have 2 types of magnetic circuits, core type, shell type. So recently in previous exams also we have questions on this core shell. In core, which one surrounds which one? Winding surrounds the core or core surrounds the winding? If we take core type transformer, winding will surrounds the core, means winding will come outside, core will go inside. And if you take shell type transformer, core will surrounds the winding, and which is suitable for high voltages, low currents. High voltage, low current we use core type, and shell type we preferred for low voltage, high power or high current applications. Like that, some important points we need to focus these differences between core type and shell type. Which one will have more leakage? Core will have more leakage, shell will have less leakage flux. Next, from transformer winding. Winding placement important. So out of the 2 winding, what type of winding? 2 cores, core type, shell type we have. What type of winding we use in core type? In core type we use what type? Concentric and interleave winding procedure. But in shell type we use sandwich winding procedure. Sandwich winding procedure in shell type. And out of LV winding, HV winding, which winding is preferred to place first on the core? LV or HV? We preferred LV winding to be placed first on the core, because some advantages we have. Insulation required is less, copper required is less, leakage flux reduces, and we can provide tappings easily on HV, because HV winding will come outside when you place LV winding inside. So some advantages we have there. That's why which winding is always preferred to place first on the core? LV winding. Okay. Next, in operation of transformer, what we need to focus from operation? In the operation of transformer, mainly we have 2 cases, no load operation and load operation. In the no load operation, we will get 2 components of current. One is total no load current is sum of 2 currents. One is magnetizing current and iron loss current. Iron loss component or working component we call IW. And what is I mu? I mu in terms of I naught. I mu is I naught sin phi naught and IW is I naught cos phi naught. This equation is important. This is I naught sin phi naught and IW I naught cos phi naught. And no load power factor of transformer generally less than 0.5 will be there. Remember this point. Next, this is no load components. And also we have equivalent circuit parameters R naught, X naught. These are all you should look once. Next, in the load operation, whenever load connected to the transformer, on the primary side, a current will flow, that is called I1 dash, which is load component of primary current. Then totally under load condition, what is the current drawn by transformer? I1. This is the sum of 2 currents. One is no load current, plus load component of primary current. And what is the equation for I1 dash? It depends on secondary current or load current, that is K times I2. Okay. Now remember these points from no load and load operation. And what is the flux in the core? It is a constant flux device and constant power device. Next, we have to focus mainly on iron loss topic. Iron loss. So iron loss is the sum of two losses mainly. They are hysteresis and eddy current loss. Now here we have two cases. These two cases we should remember. So those who already know subject, you can understand these points. And those who don't know anything here, you cannot understand directly these points. Okay. Now in two cases, they are V1 by F ratio constant. So the iron loss topic important because manaki so many times regular questions unnai AE type of examinations lo in state level. So you should focus these two cases. V1 by F constant case lo hysteresis loss proportional to frequency and eddy current loss proportional to frequency square. Direct questions on these relations unnai manaki. Next, whenever voltage to frequency ratio is not constant, so how to know ivi manaki ela telusta voltage frequency constant kada anedi. So this depends on manaki ichina data ni question ni batti we have to understand how they are changing voltages and frequencies. They are changing proportionally or not. Ee ratio check cheskondi. V by F value same unda leda. If it is not same, case 2 it is. In case 2 we have hysteresis loss proportional to V1 power 1.6, F power minus 0.6 and eddy current proportional to V1 square. Okay. So these two cases important iron loss. So definitely either theory questions or numerical questions we can expect from this iron loss topic. Next, copper loss. Copper loss lo important. Copper loss anedi I square R loss. But sometimes we have some numericals in terms of percentage copper loss. What is the percentage copper loss? Percentage copper loss equal to nothing but it is the ratio of full load copper loss divided by volt ampere rating into 100 percentage. So this percentage copper loss is nothing but percentage resistance of transformer only. So we get one relation in the percentage R. Percentage R, percentage copper loss, both are same. So edaina question lo percentage R undi ante meaning copper loss is there in the question. Okay, remember this. And copper loss is variable loss which depends on current variation. How to find copper loss at any fraction of full load? X full load is copper loss X square into full load copper loss. Suppose if you want half full load, 1 by 2 whole square into full load copper loss. Next, from open circuit and short circuit test, what we need to focus. So you should know if they give an OC data, they may ask some parameters. So by conducting OC test, which parameters or what is the objectives of OC test, what we are doing in OC test. The main purpose is to find iron loss or core loss or constant loss and to find shunt branch parameters R0, X0 and third one to separate iron loss into hysteresis and eddy current. So you should know all these procedures whenever they give some OC data. OC data lo em untai manaki there will be voltage because OC test we do at rated voltage, rated frequency and no load current and wattmeter reading. Voltmeter reading, ammeter reading, wattmeter reading. These three will be there. So by using these three readings, we have to find the objectives of that OC test. And OC test is preferred to do on which side? LV side with open circuit on HV side. Due to some advantages unnai manaki. Low voltage side aithe we can give low voltage source required, low capacity voltmeter required. So even easy available. That's why we prefer to do OC test on LV side. OC test on LV side. And short circuit test we do on HV side. With which winding is shorted? LV is shorted. Test is done on high voltage side. And in the short circuit test important is how much voltage we need to apply. Short circuit test we do at rated current but not rated voltage. No? Rated current we do. OC test we do at rated voltage and rated frequency. But short circuit test at rated current only. That's why how much voltage we need to apply is a small voltage we need to apply. What is the percentage of that small voltage? 5 to 8% of voltage we need to apply. So no need to apply rated here, 5 to 8% or 5 to 10 approximately. So in this range when you apply you will get rated current. Now using short circuit test we can find copper loss, or we can find series branch parameters, or percentage R, percentage X, percentage Z. So these objectives important from OC and SC test. You should have clarity first. If they given some data on OC and SC, what we need to do? How can we find that parameters and all? Okay. Next, efficiency law. Efficiency is important. Efficiency important is condition for maximum. At which power factor we get maximum? Maximum efficiency we will get at unity power factor, one condition. And at which load current, or at which percentage of load we get maximum efficiency, that is X. Square root iron loss divided by full load copper loss. So this is the value of X where we get maximum. X means percentage of load. And what percentage? 17 or 18 or at which percentage of load we get maximum efficiency. Okay. So it is important here, X calculation. And what is the losses? Condition for maximum efficiency. Copper loss must be equal to iron loss. Or what is the total loss at maximum efficiency? 2 times of iron loss. Because iron plus copper equated to iron there. So 2 times of iron loss is the total loss at maximum efficiency. Okay. Next, efficiency graph kuda important. Efficiency graph like this. Efficiency versus current will be there. And this is the graph. This is the maximum efficiency. Let this is full load. At maximum efficiency, what is the condition? Copper loss equals to iron loss. But at full load, this is full load. Let this is no load, zero current. At full load, what is the loss? Which loss is greater? At full load, copper loss is greater than iron loss. So like this, we have some questions in the previous exam. Next, voltage regulation. So this is important. So here voltage regulation mainly conditions important. Condition for maximum regulation, condition for zero regulation. And where regulation will be zero. Regulation ekkada zero avutundi generally? Leading power factors we get zero regulation. And where we get negative regulation also? Leading power factor. Leading only we have negative, positive and also zero. But positive is very small region, but most of the region negative will be there and zero also will be there. But for lagging power factor and unity power factor regulation anedi always positive lone untundi. And maximum regulation where we get lagging side, zero regulation we get leading side. What is condition for maximum regulation? X by R ratio of load is equal to X by R ratio of transformer. Don't say reverse it is. Condition for maximum vachi X by R of load equal to X by R of transformer. But condition for zero, X by R of load equal to 1 by X by R of transformer. Reciprocal we call it is. So this condition is important. So the regulation curve anedi important. So go through that regulation curve once. So some questions directly we may get from curve itself. Okay. And what is the formula for regulation? At any power factor, percentage R cos phi plus R minus percentage X sin phi. So use plus in that for lagging and use minus for leading power factor. Suppose they given UPF, what is the regulation? Percentage R only directly. Okay. Next, in three-phase transformers, which topic or which points we need to focus mainly is voltage, current, kVA calculation. In three-phase, what is the kVA rating of transformer? √3 VLIL in terms of line values. And here generally confuse when to take √3, when to take 3. 3 anedi 3 V phase, I phase. When you use phase voltage, phase current, then 3 times. Otherwise, line is √3 VLIL only we take. Okay, kVA. Then from this, if they ask secondary current I to L, kVA rating divided by √3 into secondary line voltage you have to take. So this type of calculations, primary current or secondary current or primary voltage, line or phase. So only depends on connection, whether the connection is delta star or star delta. So దీన్ని బేస్ చేసుకొని we have to find phase current, line currents. Okay. So the three phase is important. And ఇంకా మనకి delta delta, star star, delta star, star delta. So ఈ connections లో which connection is suitable for step up purpose mainly? Delta star. And which is for step down? Star delta we use. And there is some voltage relations in all these connections, delta delta ఈ అన్నిట్లో ఈ కొన్ని voltage relations, input line voltage, output line voltage relations we have. See, relations you have to learn once from three-phase transformer. Not only this, we have some special connections also, like open delta connection, Scott connection. So ఇవన్నీ ఒకసారి మీరు చూసుకోవాలి before examination. నెక్స్ట్ parallel operation లో important is conditions. Which are the necessary conditions, which are the desirable? Which are the necessary? Voltage rating necessary, polarities, phase sequence, phase displacement. Ivi necessary conditions. Which are desirable? Desirable are mainly impedance condition, that is impedance inversely proportional to kVA rating, or per unit impedance of two transformers should be equal based on their own kVA rating. And another condition, x by r ratio of two transformers must be equal. So these are desirable conditions. So these conditions nunche mostly manaki questions will be there directly from parallel operation. Next inka lastly auto transformer lo most of the questions is kVA rating. What is the kVA rating of auto transformer? They will give two winding transformer kVA. kVA rating of auto transformer is 1 by 1 minus k times of kVA rating of two winding transformer. Ee formula gurtu pettukondi. So whenever they give two winding transformer kVA, use this to find auto transformer kVA. So like that, there are some more relations. What is the percentage regulation, voltage regulation of auto transformer when compared to two winding? Emothun 1 minus k times of k percentage regulation of two winding transformer. Like that, weight of copper kuda 1 minus k ne. Ila konni relations unnai. From this we may get directly questions. Okay, so auto transformer many times questions kVA rating calculation. Next, DC machines nunchi which topics, which points important, let's see briefly once. Construction lo we have so many parts, stator frame or yoke we call. Next, field poles, commutator, brushes, armature core, armature winding. వీటన్నిటిలో material, what is the material used for commutator? Hard drawn copper we use. Brushes, carbon material, armature core, silicon steel, and stator frame made up of cast iron or cast steel. Okay, so these materials important here. Next, types of DC machines lo important వచ్చి regularly మనకు ఉన్న questions లో KVL equations. Suppose shunt generator is there. What is the equation? Or separately excited motor. So ఈ అన్నిట్లో generators, motors లో అన్నిట్లో we should write KVL. Suppose if you take example shunt generator, what is the KVL equation of this? EG equal to V plus IARA, and IA is what here? IL plus ISH avutundi figure lo. And what is ISH? V divided by RSH. So whenever they give some shunt generator data, EG is this. Similarly, motor aithe em avutundi equation? If it is shunt motor, V equal to EV plus IARA, and EB equal to V minus IARA. So ikkada generally people will confuse. Generally ikkada confuse avutaru when to take plus minus. First figure draw cheyandi and put the data in that, and then write the KVL equation. Antekani directly don't write equations, you may get sometime wrong equations. So in types of DC machines lo you should know clarity, how many types total, and KVL equation of each one. Okay, next, armature reaction. There are two effects in DC machine: demagnetizing effect, cross magnetizing effect. Now during armature reaction, manaki main flux anedi distorted avutundi, distorted wave. So as flux distorted, most of the flux will concentrate at one pole tip. In a generator, at which pole tip flux density increases? Trailing pole tip we call. And which pole tip flux will decrease? That is leading pole tip. Generator aithe, ade motor aithe reverse lo cheppali. Okay, these points important. And armature reaction lo we have again methods to reduce effects of armature reaction. What are the methods? By using a strong main flux or compensating winding or interpoles. See, compensating winding, interpoles important. Interpoles located on which axis? Interpolar axis. Okay, and interpole winding and compensating winding ఈ రెండు ఎలా కనెక్ట్ చేస్తాం మనం ఆర్మేచర్తో? సిరీస్లోనే కనెక్ట్ చేస్తాం. Interpole winding, compensating winding, both connected in series with armature always to reduce effects of armature reaction, both cross magnetizing and demagnetizing effect. Next, ఈ మెథడ్స్ ఇంపార్టెంట్ ఆర్మేచర్ రియాక్షన్లో. తర్వాత గ్రాఫికల్ రిప్రజెంటేషన్లో మనకి షేప్స్ ఉన్నాయి. షేప్ ఆఫ్ మెయిన్ ఫ్లక్స్ ఈజ్ వాట్? ఫ్లాట్ టాప్. షేప్ ఆఫ్ ఆర్మేచర్ ఫ్లక్స్ ఈజ్ కాల్డ్ సాడిల్ షేప్. షేప్ ఆఫ్ రిజల్టెంట్ ఫ్లక్స్ ఈజ్ పీకీ వేవ్. అండ్ షేప్ ఆఫ్ ఆర్మేచర్ ఎంఎంఎఫ్ ఈజ్ ట్రయాంగులర్ షేప్. ఓకే, నెక్స్ట్ కమ్యుటేషన్లో వాట్ ఆర్ ద రీజన్స్? మనకి వాట్ ఈస్ ద టైప్ ఆఫ్ కమ్యుటేషన్? వీ హ్యావ్ డిలేడ్ కమ్యుటేషన్. డిలే, దానివల్ల మనకి స్పార్క్స్ వస్తున్నాయి బ్రష్ దగ్గర. Now, what are the reasons for delayed commutation? Two reasons. Okati reactance voltage, another one cross magnetizing effect. So these two are the reasons for delay. Now, how to improve commutation? What are the methods? Emunai methods manaki? First one, resistance commutation we call. How to achieve resistance commutation? By using carbon brushes use chesi manam ee commutation ni improve chestam. By using carbon brushes, commutation will improve. Means spark will reduce there. Next, second, interpole commutation. By placing interpoles also we can reduce this spark at brush, or we can improve the commutation. And one more method, brush shifting. In which direction we have to shift to improve commutation? Cheppandi ఏ direction లో brush ni shift చేయాలి? In the direction of generator direction shift చేయాలి, or in opposite direction of motor shift చేయాలి. Motor ఇస్తే opposite to motor చెప్పాలి, generator ఇస్తే same direction, generator direction లో shift చేయాలి. ఓకే. నెక్స్ట్ క్యారెక్టరిస్టిక్స్లో మనకి ఇంపార్టెంట్ వచ్చి సిరీస్ జనరేటర్ క్యారెక్టరిస్టిక్స్ ఇంపార్టెంట్, సిరీస్ మోటార్ క్యారెక్టరిస్టిక్స్ ఇంపార్టెంట్. ఆ షేప్స్ గుర్తుండాలి అన్ని. షంట్ జనరేటర్ క్యారెక్టరిస్టిక్స్ ఎలా ఉంటాయి? డ్రూపింగ్. షంట్ జనరేటర్ డ్రూపింగ్ క్యారెక్టరిస్టిక్స్. సిరీస్ జనరేటర్ రైజింగ్ క్యారెక్టరిస్టిక్స్, దట్ ఈస్ వేరియబుల్ వోల్టేజ్ సిరీస్ జనరేటర్. అండ్ షంట్ మోటర్ speed torque characteristics, slightly speed of the motor decrease whenever torque increase. But what is the shape of series motor? Important ikkada. Series motor lo shape of speed torque characteristics is what? Rectangular hyperbola. No load, dangerous high speed, and whenever load increase, speed of the motor quickly decrease. Rectangular hyperbola shape. And what is the speed in a series motor? Torque IA characteristics. Before saturation, torque IA is parabola. After saturation, torque IA is straight line. Because when you draw a line, so much time it will take. That's why I am giving orally these points, so that you have to remember, you have to catch the points quickly. Torque IA before saturation, parabola, after saturation, straight line. Okay, mainly series motor, series generator, shunt motor, important characteristics. Okay, next, speed control methods. What are the methods of speed control? Mainly three: flux control, armature resistance control, and voltage control method. Now, out of these, for above rated speed or high speed control challenge, which methods we have to use? Flux control. So flux control is suitable for above rated speed. Ikkada ee graph important, drive graph, torque and power drives, and this is speed, rated speed, below rated, above rated. So below rated torque is constant, above rated torque is variable. Below rated power is linearly varies or variable, above rated power is constant. Now, which methods for above rated? Flux control method. Which methods for below rated? Armature resistance control, voltage control method. So you may get question, under flux control method, the motor behaves as dash. The flux control method means above rated. The motor behaves as constant power, variable torque drive. Okay. So ilanti questions directly from speed control, or they may give some question related to speed control method. So ivanni teliyali, you should know in detail all these methods to answer the questions. Next, braking. So braking lo how many methods we have? Particularly electrical braking if you talk. Any methods una? Three methods: resistance braking, yes, resistance braking, plugging, and regenerative braking. These three brakings we have electrical brakings. So what is the procedure for dynamic braking? Dynamic braking lo manam armature ni from supply, we have to remove the armature from supply and connect a resistor across armature, brake applied. And for plugging, what is the procedure? During plugging, the armature should reverse with respect to supply polarities. The armature should reverse, armature terminals should be reversed with respect to supply. Hello everyone, sorry for the disturbance, internet issue is there. Now let's see for synchronous machines. Out of the previous braking of motors, which braking is efficient? Regenerative braking is efficient brake, remember this. Now let's see synchronous machines. So every part of machine lo manam 2 to 3 questions aithe we can expect. 2 to 3 questions. Actually 3-4 questions also we may have in the previous exams, but right now ఈసారి సిలబస్ ఎక్కువ ఉంది కాబట్టి we can have some little less questions, 2 to 3, and an average 10 to 12 questions we can expect from machines total. Okay, first construction lo ikkada kuda manaki stator rotor 2 parts unnai, and what is the material we use for both stator and rotor? Silicon steel only we use here. We have 2 types of rotors. What are that? Salient pole rotor and cylindrical pole rotor. So out of these two, ఈ రెండిట్లో ఏది హై స్పీడ్ అప్లికేషన్కి మనం యూజ్ చేస్తాం? సిలిండ్రికల్, దాన్ని టర్బో ఆల్టర్నేటర్స్ అంటాం. అండ్ సేలియంట్ పోల్ వి యూజ్ ఫర్ లో స్పీడ్ అప్లికేషన్, పర్టికులర్లీ మన హైడ్రో పవర్ ప్లాంట్స్లో హైడ్రో ఆల్టర్నేటర్స్, ఈ హైడ్రో ఆల్టర్నేటర్స్ వి కాల్ సేలియంట్ పోల్ ఆల్టర్నేటర్, ఆల్సో కాల్ హైడ్రో ఆల్టర్నేటర్, బికాస్ మనం హైడ్రో పవర్ స్టేషన్స్లో ఇవే యూజ్ చేస్తాం. బికాస్ ఇక్కడ టర్బైన్ స్పీడ్స్ అనేది లో ఉంటుంది, బికాస్ ఈ సేలియంట్ పోల్ అనేది సూటబుల్ ఫర్ లో స్పీడ్ ఓన్లీ, కాబట్టి ఈ టర్బైన్స్ వీటికి సూటబుల్ హైడ్రల్ టర్బైన్స్. నెక్స్ట్ ఈ కన్స్ట్రక్షన్లో ఇంపార్టెంట్ ఈస్ మనకు ఒక టాపిక్ ఉంది హంటింగ్. హౌ టు ఎలిమినేట్ హంటింగ్ ఇన్ ద సేలియంట్ పోల్ ఆల్టర్నేటర్స్ బై యూజింగ్ డాంపర్ వైండింగ్. ఈ డాంపర్ వైండింగ్ యూజ్ చేసి వీ కెన్ ఎలిమినేట్ హంటింగ్. ఈ పర్టికులర్లీ హంటింగ్ టాపిక్లో డాంపర్ వైండింగ్స్ విల్ డెవలప్ సమ్ టార్క్. ఆ టార్క్ని ఏమంటాం మనం? ట్రాన్సియంట్ టార్క్ అంటాం. ట్రాన్సియంట్ టార్క్ అంటే ఈ జస్ట్ ఫర్ షార్ట్ టైం మాత్రమే ఈ టార్క్ ఉంటుంది, తర్వాత ఆటోమేటిక్లీ ఇది స్టడీ స్టేట్కి రీచ్ అయిపోతుంది. సో ద టార్క్ డెవలప్డ్ బై డాంపర్ వైండింగ్ ఆర్ డాంపర్ బార్స్ ఈస్ కాల్డ్ ట్రాన్సియంట్ టార్క్, విచ్ మే బీ ఇండక్షన్ మోటార్ టార్క్ ఆర్ ఇండక్షన్ జనరేటర్ టార్క్. అది ఇండక్షన్ మోటార్ టార్క్ అయినా అవ్వచ్చు, జనరేటర్ టార్క్ అయినా అవ్వచ్చు. సో వెన్ ఇండక్షన్ మోటార్ టార్క్ విల్ డెవలప్ whenever speed of alternator drops below synchronous speed, అప్పుడు ఇండక్షన్ మోటార్ టార్క్ జనరేట్ అవుతుంది, మీన్స్ స్పీడ్ బికమ్ లెస్ దాన్ సింక్రోనస్. If the same speed of alternator becomes more than synchronous, then induction generator torque will develop. So induction motor torque అనేది రోటర్ని యాక్సలరేట్ చేస్తుందా, డిసలరేట్ చేస్తుందా? యాక్సలరేట్. మోటార్ టార్క్ అనేది ఆల్వేస్ యాక్సలరేట్ చేస్తుంది, బట్ ఇండక్షన్ జనరేటర్ టార్క్ అనేది రోటర్ని డిసలరేట్ అంటే స్పీడ్ని తగ్గిస్తుంది, బికాస్ స్పీడ్ ఇంక్రీజ్ అయింది కదా మోర్ దాన్ సింక్రోనస్. సో ఆ స్పీడ్ మళ్ళీ కమ్ బ్యాక్ టు నార్మల్ స్పీడ్స్. ఓకే, నెక్స్ట్ ఆర్మేచర్ వైండింగ్ టాపిక్లో ఇంపార్టెంట్ టర్మ్స్ అంటే మనకి 2 types of winding we use here. They are short pitch winding and distributed winding. Short pitch distributed. So why we use short pitch winding? And by using short pitch winding, which harmonics we are eliminating? To eliminate harmonics, we use these 2 windings: short pitch winding, distributed winding. Short pitch winding use chesi which harmonics we can eliminate? 5th and 7th. Remember this point. Short pitch use chesi which harmonic we are eliminating? 5th and 7th. So how much angle required to eliminate 5th harmonic? So ఇక్కడ మనకి షార్ట్ పిచ్ యాంగిల్ ఉంది, ఆల్ఫా వి కాల్. ఆల్ఫా ఫార్ములా ఈజ్ 180/n. ఇఫ్ యూ వాంట్ టు ఎలిమినేట్ ఎనీ హార్మోనిక్, 5th అయినా 7th అయినా వాట్ ఎవర్, ఆల్ఫా ఈజ్ 180/n. సపోజ్ ఇఫ్ యూ వాంట్ టు ఎలిమినేట్ 5th, 180/5, 36 degrees, ఆర్ 180/7, 7th harmonic. So anything you can eliminate by keeping some short pitch angle alpha, that alpha is 180/n. And coil span beta equal to 180 into n minus 1/n. This is coil span beta we call. And sum of these two, alpha plus beta, short pitch angle alpha, beta is coil span. Coil span ante distance between 2 coil sides we call coil span. That sum of alpha plus beta is always 180 degrees. Okay, and this is short pitch winding nunchi. And similarly we have distributed winding. In distributed winding we get short pitch winding lo manaki a factor vastundi, pitch factor kp, what is alpha by 2. And distributed winding lo we get kd, distribution factor, which is sin m gamma by 2 divided by m sin gamma by 2. ikkada gamma ante slot angle. What is the formula for slot angle? 180/s/p, slots per pole. M is nothing but slots per pole per phase is m, so indicated with slot per pole per phase it is. So this is distribution factor and pitch factor. So by using pitch, short pitch winding, which harmonics eliminated? 5th, 7th. And by using distributed winding, which harmonic we are eliminating? Remember this, 3rd harmonic. And here 5th and 7th harmonic we eliminate. So totally 3, 5, 7. These dominant harmonics we eliminate. Only fundamental will be there, higher order neglecting. So the shape of EMF will become sinusoidal here. Okay, no? Next. armature reaction. Deentlo important armature reaction of synchronous machines mainly depends on power factor of load. Manaki different power factors unnai, lagging, leading, unity power factor. So what is the effect of reaction for UPF? Cross magnetizing effect. What is the effect of reaction for lagging power factor? Lagging ante RL load. If there is R, cross magnetizing. If there is L, demagnetizing. Ante both will be there. If lagging is connected, some 0.8 lag, the armature reaction is both cross magnetization and demagnetization. If load is leading power factor, means RC load, then we have cross magnetizing effect and magnetizing effect. When there is capacitive nature, magnetizing effect. When there is inductive nature, demagnetizing effect. So ivanni power factors meeda depend avutayi, synchronous generator particularly. Ade motor aithe oppositely you have to say. Inductor for generator what happened? Demagnetize. Same inductive load for motor aithe, or lagging power factor if motor is operating, the armature reaction is cross magnetize and magnetizing. ఇవన్నీ కొద్దిగా కన్ఫ్యూజ్ అవుతారు. రెసిస్టెన్స్ అయితే క్రాస్ మ్యాగ్నటైజ్, ఫర్ జనరేటర్ ఐఎమ్ సేయింగ్. ఇండక్టర్ అయితే డీమాగ్నటైజింగ్, అండ్ కెపాసిటివ్ నేచర్ అయితే ఇఫ్ లోడ్ కనెక్టెడ్ ఈస్ కెపాసిటివ్ నేచర్, మ్యాగ్నటైజింగ్ ఎఫెక్ట్. సో బేస్డ్ ఆన్ దిస్ యూ హ్యావ్ టు ఆన్సర్. సో వెన్ ఆల్టర్నేటర్స్ ఆర్ ఓవర్ ఎగ్జైటెడ్, ఇండక్టివ్ లోడ్స్ కనెక్ట్ చేసినప్పుడు మనం ఓవర్ ఎగ్జైట్ చేయాలి. When alternator is said to be normal excited, resistive load అయితే normal excited we call. And whenever alternator supplying capacitive loads, then alternators are under excited to maintain constant terminal voltages. Okay, so next, ఈ voltage regulation లో again where regulation 0, where regulation negative, ఆల్రెడీ మనం ట్రాన్స్ఫార్మర్లో డిస్కస్ చేసిన సేమ్ పాయింట్స్ ఇక్కడ కూడా వస్తాయి. రెగ్యులేషన్ 0 అనేది ఎక్కడ వస్తుంది? లీడింగ్. నెగిటివ్ కూడా లీడింగ్లోనే వస్తుంది. లాగింగ్ యూపీఎఫ్లో ఆల్వేస్ రెగ్యులేషన్ పాజిటివే ఉంటాయి. ఇక్కడ కండిషన్స్ ఇంపార్టెంట్. వాట్ ఈస్ ద కండిషన్ ఫర్ జీరో రెగ్యులేషన్? కండిషన్ ఫర్ జీరో రెగ్యులేషన్ ఈస్ కాస్ ఆఫ్ థీటా ప్లస్ ఫై ఈక్వల్ టు మైనస్ ఐఏజెడ్ఎస్ డివైడెడ్ బై 2v. కాస్ ఆఫ్ థీటా ప్లస్ ఫై. And for maximum regulation, what is the condition? Load power factor angle must be equal to impedance angle. ఈ impedance angle ఎలా వస్తుంది? Synchronous impedance ఉంటుంది కదా, ZS, RA plus JXS. What is impedance angle? Tan inverse XS by RA will give impedance angle. So దాన్ని ఈ power factor angle తో ఈక్వేట్ చేయాలి. So equate power factor angle with this impedance angle. So whatever the angle you got, apply cos to that, then you get power factor where we get maximum regulation. Zero regulation, maximum regulation. Okay, ఈ రెగ్యులేషన్లో వీ హ్యావ్ సమ్ మెథడ్స్ టు ఫైండ్ వోల్టేజ్ రెగ్యులేషన్ ఇన్ ఆల్టర్నేటర్స్, పర్టికులర్లీ లైక్ ఈఎంఎఫ్ మెథడ్, ఎంఎంఎఫ్ మెథడ్, జెడ్పిఎఫ్ మెథడ్, ఏఎస్ఏ మెథడ్. సో ఇక్కడ ఇంపార్టెంట్ వచ్చి మనకి జనరల్లీ ఈఎంఎఫ్ మెథడ్ ఈస్ కాల్డ్ డాష్ పెసిమిస్టిక్ మెథడ్, బికాస్ ఈఎంఎఫ్ మెథడ్ విల్ గివ్ ద రెగ్యులేషన్ మోర్ దాన్ యాక్చువల్ రెగ్యులేషన్. సపోజ్ యాక్చువల్ 25% అయితే మనకి 30% చూపిస్తుంది ఈ ఈఎంఎఫ్ మెథడ్లో. దట్ ఈస్ కాల్డ్ పెసిమిస్టిక్ మెథడ్, పెసిమిస్టిక్ నేచర్. But MMF method, if you use to find the regulation, దీంట్లో మనకి actual 25 అయితే you will get some 20-21, less than that. That is called optimistic method. Okay, EMF method is pessimistic and MMF method is optimistic method, and ZPF method will give little accurate value of regulation, that is accurate method. Okay, next, characteristics లో particularly load saturation characteristics important. ఎలా ఉంటాయంటే లోడ్ సాచురేషన్ V వర్సెస్ IF ఫర్ డిఫరెంట్ టైప్స్ ఆఫ్ లోడ్స్, యూపీఎఫ్ లోడ్, లాగింగ్ లోడ్, లీడింగ్ లోడ్. సో ఇలా మీకు కొన్ని కర్వ్స్ ఇచ్చి విచ్ కర్వ్ ఈజ్ ఆపరేటింగ్ ఎట్ హైలీ స్టేబుల్, విచ్ కర్వ్ ఎట్ ఫర్ విచ్ కర్వ్ ఆల్టర్నేటర్ ఈజ్ హైలీ స్టేబుల్, విచ్ వన్? ఏ. బికాస్ హైలీ స్టేబుల్ అంటే ఎలా ఉండాలి? జనరల్లీ ఓవర్ ఎగ్జైటేషన్, ఫీల్డ్ కరెంట్ వెన్ వీ ఇంక్రీజ్, కోఎఫిషియంట్ ఆఫ్ కప్లింగ్ అనేది ఇంక్రీజ్. Whenever field current increase, that type of alternator will be more stable. Simply, over excited alternators are highly stable or more stable. See, curves lo which curve is having high field current? A. Curve A is representing with highest field current here. Curve B field current decrease, curve C field current decrease. So higher the field current means field current nothing but excitation. Over excited alternator highly stable. So ilanti graph ichi they may ask which is more stable or which is operating at lag, which is operating at lead. So here A operating at lagging power factor we always over excite, leading power factor we always under excite. Let this is unity power factor, normal excite. So ilanti graphs important. Next, ఈ పవర్ ఈక్వేషన్స్లో వీ హ్యావ్ టూ ఆల్టర్నేటర్స్ కదా, సిలిండ్రికల్ పోల్ ఆల్టర్నేటర్, సేలియంట్ పోల్ ఆల్టర్నేటర్. ఈ రెండు ఈక్వేషన్స్ ఇంపార్టెంట్. సిలిండ్రికల్ పోల్ ఆల్టర్నేటర్ అయితే వాట్ ఈస్ ద పవర్ ఈక్వేషన్ విత్ నెగ్లిజిబుల్ రెసిస్టెన్స్ ఈస్ ఈవీ బై ఎక్స్ఎస్ సైన్ డెల్టా. Okay, and with salient pole alternator, if it is salient pole alternator, what is the power equation? Here two powers will come. One is electromagnetic and reluctance power. They are EV by XD sin delta plus V square by 2 sin 2 delta into 1 by x cube minus 1 by xd. ఇక్కడ కొద్దిగా కన్ఫ్యూజ్ అవుతూ ఉంటారు. This is 1 by xd. Okay. 1 by x cube minus 1 by xd. Generally ఇక్కడ 1 by xd minus 1 by x cube తీసుకుంటారు by mistake ఎగ్జామ్స్లో. This is called reluctance power. దీన్నే మనం reluctance power అంటాం. This is called electromagnetic power. So electromagnetic power depends on xd only, but reluctance power depends on both xd, xq values. ఈ xd, xqలో ఏది ఎక్కువ ఉంటుంది? xd is greater. Remember, xd is greater than xq always. That difference between xd, xq we call saliency it is. Remember this. Now where electromagnetic power is maximum? Sin 90 delta. At delta 90 degrees it is maximum. But where reluctance power is maximum? This is sin 2 delta, second harmonic component. If delta is 45, then we get sin 90 here, then it is maximum. So reluctance power is maximum for delta equal to 45 degrees, but this is maximum at 90. And this one also maximum at 90 degrees. And what is the maximum power? EV by XS. Maximum is EV by XS. So power equation is important. Next, parallel operation lo conditions ఉన్నాయి. Conditions important. What are the conditions for alternator parallel operation? Constant voltage, constant frequency, or same voltage, same frequency, same phase sequence for two alternators to operate in parallel. ఈ parallel operation లో మనకి we have some topics. Two alternators parallelly operating, what the variations we have, and one alternator connected to infinite bus bar. Then what are the variations? మనం excitation variation and mechanical input or turbine input variation we call. So like these two cases we have here. ఈ total parallel operation లో మనకి many times questions వచ్చి ఈ V inverted V curves, power factor IA, this is field current. We have V curve and inverted V curve. So V curve is nothing but IA versus IF. Inverted V curve is power factor versus IF. So ఇది many times we have. V curve is drawn between dash. V is IA versus IF. Inverted V is power factor versus IF. And ఇక్కడ కొన్ని variations ఉన్నాయి. So this is the normal excitation, unity power factor. Maximum is 1, no? So minimum power factor decreases. Maximum 1, minimum 0. And minimum current, when alternators will take minimum current, at unity power factor current is minimum, and at 0 power factor current is maximum. So ఇలాంటి కొన్ని questions directly from this V inverted V graph. Next, synchronous motor lo important is starting torque. What is the starting torque of synchronous motor? 0. So they may give starting torque to full load torque of synchronous motor is dash 0 because starting torque 0 here. And what are the methods we use to start the synchronous motor? Mainly we use auxiliary motor starting or damper winding starting we use. And ఇక్కడ కూడా EMF equations ఉన్నాయి, అవి important for synchronous motor. So go through it once. Next, finally induction machines లో construction. Again stator, rotor. What is the material used for stator, rotor? Same silicon steel. Silicon steel only we use, CRGO only in transformer we use, no other rotating machines. Next, ikkada rotor is two types, squirrel cage rotor, slip ring rotor. Now out of the squirrel cage and slip ring, there are some advantages and disadvantages of each one, squirrel cage and slip ring. Squirrel cage rotor will have heavy size copper bars and short circuited with end rings. But in slip ring rotor, we have a three-phase star connected rotor winding that is connected, short circuited through slip rings and brushes. So what is the need of that slip ring brush arrangement is, if you want to control starting currents or if you want to control speed of the motor by rotor resistance method, and all this we use that slip ring brush arrangement here so that we can control easily that slip ring induction motor. We can increase starting torque also by adding resistance in the rotor circuit through slip rings and brushes, which is not possible in case of squirrel cage induction motor. So which motor will have high starting torque? Slip ring. But how to increase starting torque of squirrel cage little bit? By skewing the rotor slots, one method, or by using double cage rotor or deep bar rotor also we use to increase the starting performance of squirrel cage induction motor. Okay, next torque equations important ikkada. Torque equations. So before that manaku power equations lo rotor input power, rotor copper loss, rotor mechanical power, gross power or output power. The relation is what? 1 is to S is to 1 minus S. ఇది రోటార్ ఇన్పుట్, రోటార్ కాపర్ లాస్, రోటార్ అవుట్పుట్. రోటార్ అవుట్పుట్ మెకానికల్ పవర్, గ్రాస్ పవర్ ఇట్ ఈస్ వి కాల్. బట్ విచ్ పవర్ వి టేక్ అవుట్ సైడ్? షాఫ్ట్ ఓన్లీ నా వి టేక్ అవుట్ సైడ్, దట్ ఈస్ కాల్ షాఫ్ట్ పవర్. ఈ రిలేషన్ ఇంపార్టెంట్. అండ్ టార్క్ ఈక్వేషన్స్. సో ద బేసిక్ టార్క్ ఈక్వేషన్ ఈస్ T ఈక్వల్ టు 180 by 2 pi ns into S E2 square R2 divided by R2 square plus SX2 square. So ikkada so many times manaki questions vachi torque equation nunchi condition for maximum torque is dash. What is the condition for maximum torque? Slip at maximum torque is R2 by X2. And at maximum, for maximum starting torque, what is the condition? Condition for maximum torque vachi SM equal to R2 by X2. Now what is the condition for maximum starting torque? Maximum torque vachi idi starting ante దీన్ని equate to 1. Then how to get maximum starting torque? Starting torque ఎక్కువ రావాలి అంటే, maximum రావాలి అంటే we need to add some resistor in series with rotor. So R2 plus RE ని add చేస్తే you will get. So they may ask you that question, find the external resistance required to get maximum starting torque. They will give R2 X2 in the data, only RE we need to calculate. ఇది 1 కి equate చేయాలి. So ఇలాంటి కొన్ని కండిషన్స్. కండిషన్ ఫర్ maximum mechanical power is what? And what is the relation between full load torque to maximum torque? We have some relation, no? What is that? 2SM SFL divided by SM square plus SFL square. So ఇలాంటి starting torque to maximum torque 2SM by 1 plus SM square. So ఈ relations అన్ని important. Next, tests on motor. What are the tests we conduct on the motor? No load test, block out rotor test. Similar to induction transformer lo manaki ela aithe OC test, AC test unnayo, same procedure almost for this no load test and block out rotor test. Okay, and speed control methods. So there are so many methods for induction motor speed control. DC motor aithe easy gurtu pettukodaniki, adi only 3 methods kabatti: flux control, armature resistance control, voltage control in DC motor. కానీ ఇక్కడ there are so many methods, like we have voltage control method, rotor resistance control method, frequency control, pole changing technique, cascading of induction motors, cascading, and EMF injecting method. So again, వీటిలో some methods are suitable for above rated, some methods for below rated, and some suitable for squirrel cage, some suitable for slip ring. Voltage control it is suitable for below rated. Voltage control ఏ మోటార్ అయినా సరే below rated కి suitable, above rated కి not suitable. Rotor resistance కూడా below rated only. Frequency లో again we have 2 methods: pure frequency control method and V by F control method. Variable voltage, variable frequency control method we call pole changing technique. ఈ pole changing technique అనేది particularly squirrel cage కి suitable. Slip ring కి ఇది difficult, that's why we don't use. And cascading of induction motors, cumulative cascading, differential cascading. ఈ cascading లో main motor must be slip ring type and auxiliary motor may be squirrel cage or slip ring type, but main motor అనేది slip ring ఏ అవ్వాలి ఈ cascading లో. Next, EMF injecting. This method suitable for slip ring only. ఎందుకంటే మనం EMF injecting రోటర్ నుంచి ఇంజెక్ట్ చేస్తాం EMFని. సప్లై విల్ బి దేర్ టు స్టేటర్, నో. ఈ EMFని మనం రోటర్ నుంచి యాడ్ చేస్తాం through slip ring and brushes. That's why it is suitable for slip ring induction motor. So ikkada you have to little concentrate which methods for above rated, which methods for below rated. ఇవన్నీ ఒకసారి రాసుకోండి side by which for above rated by looking in your notes. Already notes ఉంటే మీ దగ్గర అది చూసుకొని ఒకసారి రాసి పెట్టుకోండి సైడ్లో, which methods for below rated, which methods for above rated. Okay, next finally ఇక్కడ starting methods of induction motor. ఈ స్టార్టింగ్ మెథడ్స్లో ఒక ఈక్వేషన్ ఇంపార్టెంట్, అది స్టార్టింగ్ టార్క్ టు ఫుల్ లోడ్ టార్క్. వాట్ ఈస్ దట్? IST by IFL హోల్ స్క్వేర్ ఇంటూ SFL ఫుల్ లోడ్ స్లిప్. ఈ స్టార్టింగ్ టార్క్ టు ఫుల్ లోడ్ టార్క్, ఇక్కడ మనకు డిఫరెంట్ మెథడ్స్ ఉన్నాయి స్టార్టింగ్ మెథడ్స్లో. DOL స్టార్టింగ్, సిరీస్ రియాక్టర్ స్టార్టింగ్, సిరీస్ రెసిస్టర్ స్టార్టింగ్, ఆటో ట్రాన్స్ఫార్మర్ స్టార్టింగ్, అండ్ స్టార్ డెల్టా స్టార్టింగ్. సో మీకు మోస్ట్లీ క్వశ్చన్స్ వీ మే గెట్ ఫ్రమ్ star delta starting ani auto transformer starting ani. So దీంట్లో ఈ relations we have to write. For star delta what is the starting current, and for auto transformer what is the starting current. So equation nunchi you may get questions. Okay, so go through these methods and then check what is the starting current in each method. Even different గా ఉంటుంది కొంచెం ఈ starting current అనేది. Okay, in star delta, star is used at the time of starting and delta is used for running condition. Generally induction motor stator winding ఏ కనెక్షన్లో ఉంటుంది, డెల్టాలో ఉంటుంది. కానీ స్టార్ట్ చేసేటప్పుడు దాన్ని స్టార్లో కన్వర్ట్ చేయగలిగితే, ఇఫ్ యూ ఆర్ ఏబుల్ టు కన్వర్ట్ డెల్టా ఇంటూ స్టార్, ఇనిషియలీ స్టార్తో స్టార్ట్ చేసి వన్స్ మోటార్ పికప్స్ ద స్పీడ్ రన్నింగ్ కండిషన్లో డెల్టాలో కన్వర్ట్ చేస్తాం. సో స్టార్ టు డెల్టా, startingలో స్టార్ కనెక్షన్ ఈజ్ యూస్డ్, రన్నింగ్ కండిషన్ డెల్టా ఈజ్ యూస్డ్. ఓకే, దట్ ఈస్ స్టార్ డెల్టా స్టార్ట్. Okay, so let's see some small questions based on the previous questions. However, we are getting some models. Very few questions I am giving based on time. See this question. The EMF induced in secondary winding of a 50 Hz single phase transformer having 1000 turns on secondary is 222 volts. EMF on secondary given and turns on secondary given. The maximum flux density in the core is 0.1 Weber per meter square. Then the cross sectional area of core. Directly EMF equation use cheyandi. E2 equal to 4.44 Bm an f n2. So E equation, secondary side EMF they given, secondary side voltage, that's why. Dintlo only unknown is cross sectional area. The remaining data is given here. If you substitute, we get EMF is what, 222 4.44, flux density given 0.1 Weber per meter square, an only unknown, frequency 50, number of turns are 1000, secondary side. Simplify this, we get the value of an 0.01 meter square it is. Okay, check cheyandi calculation. Net cross sectional area, EMF equation gurtundali deeniki. Okay, next see this question. In a star delta connected three-phase transformer supplied with 11 kV, ante star side, star delta means primary star, secondary delta, supplied with 11 kV and the line current is 20 amperes. Input line voltage, input line current given 20 amperes. Per phase turns ratio is 11. The secondary line voltage and secondary line current are dashed. So they given V1L and they given I1L. What is V1L? 11 kV. And I1L 20 amperes. Now we need to calculate secondary line voltage, secondary line current I2L. How to find this? Ela kanukol. So ikkada line values given, per phase turns ratio given. So as per phase turns ratio is no, we have to convert voltages also. See, V2 phase divided by V1 phase equal to N2 phase by N1 phase. They given N1 by N2 and N2 by N1 is 1 by 11. So దీని నుంచి V2 phase ఏమవుతుంది చూడండి. V2 phase equal to V1 phase. What is V1 phase from here? Primary line voltage is 11 kV. Primary star connected, no? Primary star, secondary delta. Star కాబట్టి phase voltage is by root 3 తీసుకోవాలి. So phase voltage is 11 k by root 3 divided by 11. So it is 1000 by root 3, 577 volts we get. చెక్ చేయండి దీన్ని. ఇది ఫేజ్ వోల్టేజ్, సెకండరీ ఫేజ్ వోల్టేజ్. కానీ సెకండరీ ఏ కనెక్షన్ ఉంది, డెల్టా. సో వాట్ ఈస్ ద లైన్ వోల్టేజ్ ఆల్సో? లైన్ వోల్టేజ్ ఆల్సో సేమ్ 577 ఓన్లీ, బికాస్ లైన్ వోల్టేజ్ ఈక్వల్ టు ఫేజ్ వోల్టేజ్. సో ఇలానే I1 by I2 ఈక్వల్ టు N2 by N1 తీసుకోండి. కానీ ఇక్కడ నో నీడ్, బికాజ్ ఇలాంటి క్వశ్చన్స్ ఇచ్చినప్పుడు ఫస్ట్ మనం చెక్ చేయాలి. ఒక వాల్యూ క్యాలిక్యులేట్ చేసిన తర్వాత వీ హ్యావ్ టు చెక్ ఆప్షన్స్ ఫస్ట్. బ్లైండ్లీ చేసుకుంటూ పోతే వాట్ హ్యాపెన్, టైమ్ జస్ట్ ఓవర్. సో ఇక్కడ ఓన్లీ వన్ ఆప్షన్ విత్ 577 ఈజ్ దేర్. సో ఆప్షన్ ఏ డైరెక్ట్లీ కరెక్ట్. ఇక్కడ ఇంకా కరెంట్ని క్యాలిక్యులేట్ చేయాల్సిన అవసరం లేదు. ఓకే, బ్లైండ్లీ డోంట్ డూ ఎవ్రీ క్యాలిక్యులేషన్ ఇన్ ఎగ్జామ్. ఫస్ట్ చెక్ ద ఆప్షన్స్. నెక్స్ట్, a 20 kVA, this is from auto transformer, a 20 kVA single phase 50 Hz 2000 by 200 volt 2 winding transformer is connected as auto transformer so as to achieve a voltage ratio of 2200 by 200. What will be the rating of this auto transformer? KVA rating kanukovali. So ela kanukovali KVA rating? KVA rating of auto transformer. What is the formula for this? 1 by 1 minus k times of kVA rating of 2 winding transformer. Kanukondi. So 1 divided by 1 minus k. What is k means always? Auto transformer lo k ante low voltage by high voltage. Ikkada low voltage is 200, high voltage is 2200. 200 divided by 2200 into kVA rating of 2 winding given 20. Solve this, you will get 22 kVA. Solve cheyandi 22 వస్తుంది. 22 kVA. So this is one of the recent last year AE question in one of the exam. Next, a 6-pole 50 Hz 3-phase induction motor is running at 950 RPM and has rotor copper loss of 5 kilowatts. Its rotor input is dash. Cheppandi. Rotor input kanukovali. Copper loss given. Rotor copper loss is 5 kilowatt. What is the formula? Rotor input divided by rotor copper loss is 1 by S. So దీని నుంచి rotor input is rotor copper loss divided by S. First 6 pole అంటే synchronous speed directly you should write all this quickly 1000 RPM 6 poles ki speed ఎంత 950. What is the slip now? 1000 minus 950 ns minus n by ns 0.05 we get slip. Now substitute here. Rotor copper loss given 5 kilowatts divided by 0.05 it is. Now calculate this, we get 100 kilowatt it is. The rotor input power is 100 kilowatt. Which option? 100. Next, a double cage induction motor has better starting and running characteristics because of two of the following conditions. A double cage induction motor has better starting and running. Manam generally ee squirrel cage lo one of the method to increase starting performance is what? Double cage rotor. Not only starting, running performance also we increase there. ఈ డబుల్ కేజ్ రోటర్లో ఎలా ఉంటుంది? డబుల్ కేజ్ అంటే ఒక్కొక్క స్లాట్లో దేర్ ఈస్ 2 కండక్టర్స్. వన్ ఈజ్ అవుటర్ కండక్టర్, ఇన్నర్ కండక్టర్. ఇవన్నీ ఎండ్ రింగ్స్తో కనెక్ట్ చేస్తే వీ గెట్ 2 కేజెస్ దేర్. సపోజ్ వన్ స్లాట్ ఐఎమ్ షోయింగ్, సీ దిస్. This is one slot. In one slot there are 2 conductors. Outer conductor is small one, inner conductor is large one. So this is large conductor having large size cross sectional area. This is small conductor. ఈ outer conductor అనేది small one ఉంటుంది because outer conductor small is due to we need high starting torque. Starting లో ఏది కావాలి? High starting torque కావాలి. Running లో good running condition means in the running condition we need low copper losses. So if we use outer conductor is small one, as area is small, this resistance is high. Outer conductor will have high resistance. So because of that starting torque will increase here. So here they given inner cage has high resistance. Which cage has high resistance? Outer cage is having high resistance and low reactance. And inner cage will be opposite. Inner cage will have low resistance, this one. So 2, 3 directly you can guess. You should know just outer is what size, inner is what size. Outer is small size, inner is large size. So 2, 3, option C is correct. Next, in a 3-phase slip ring induction motor, the slip at some speed is, initial slip is given 0.05. S1 equal to 0.05. The speed is reduced by inserting external resistance in the rotor circuit and the slip becomes, after adding some external resistance in the rotor, slip increased. Slip increase means speed decrease. Speed decreases because one of the speed control method is rotor resistance control. Manam external resistance add chestundi speed will reduce. So slip is given 0.15. If the rotor winding resistance R2 is 0.2 ohm, what is the external resistance? How much external resistance is added? So me gurtunte rotor resistance control lo this ratio must be constant to have the constant torque. S by R2 ratio అనేది constant గా ఉండాలి. So from this S1 by R2 equal to S2 by after addition of resistance S2 by R2 plus R. ఈ S by R ratio అనేది constant గా ఉండాలి. So ఇప్పుడు all the values are there, only unknown is RE. So దీని నుంచి RE కనుక్కోండి. You will get the value of RE. Calculate that. So it is coming 0.4 ohms. Check it. ఇవన్నీ substitute just values. Finally rotor external resistance we need to add is 0.4 in order to increase the slip from 0.05 to 0.15, 0.4. Do the calculation chain mirror. Do the calculation. Next. The induced EMF in a armature of a lap wound 4-pole DC machine having 100 armature conductors rotating at 600 rpm with 1 Weber flux per pole is dash. Directly EMF equation. Z phi n P by Z phi n P by 60. EMF equation is substitute here. Z is given. How many conductors are there? 100 armature conductors. Flux is 1 Weber per pole. Speed is 600. Number of poles are 4 pole. Lap connected given. So 60. Lap connection A equal to poles 4 it is. So simplify this. We get 1000 volts it is. Simplified 1000 volts is the answer. Next question. A 5 kilowatt 220 volt 1500 rpm DC shunt motor runs at 1550 rpm on no load, okay, with full voltage applied. If the applied voltage is reduced to 165, initial voltage how much? 220. Shunt motor ki voltage తగ్గిస్తే speed ఏమవుతుంది అది తెలియాలి first. For a shunt motor, when you reduce the supply voltage, the speed will not change. Speed అనేది almost same అలానే ఉంటుంది. Because when voltage reduce, simultaneously ఇక్కడ field current తగ్గిపోతుంది. So as field current reduce, flux కూడా reduces. Then N proportional to E by phi relation. Voltage తగ్గితే flux కూడా proportionally reduced. So speed is almost same. 1550 అలానే ఉంటుంది. Okay, voltage control not suitable for shunt. At which of the following load power factor the alternator is said to be highly stable? Chappan answer దీనికి. Tell the answer. At which of the following load power factor the alternator is said to be highly stable? First మీకు ఒక పాయింట్ తెలియాలి ఇక్కడ. Highly stable or more stable alternator అంటే over excited alternator is more stable. Over excited. సో మనం ఆల్టర్నేటర్స్ని ఎప్పుడు ఓవర్ ఎగ్జైట్ చేస్తాం? లాగింగ్లోనా లీడింగ్లోనా? ఎస్, నో డౌట్ లాగింగ్లో వేర్ ఇట్ ఈస్ మోర్ ఎగ్జైటెడ్ there is lagging 2 options, 0.6 and 0.3. So at which power factor we give more excitation? 0.3 ka 0.6 ka? So UPF normal excitation, 0.8 lag excitation increase, 0.6 lag excitation still increase, 0.3 lag excitation still increase చేయాలి. So if you move towards zero power factor, excitation keep on increase అంటే excitation increase అవుతూ ఉంటుంది. So which is highly stable? Yes, over excited alternator which is more stable is 0.3 lag దగ్గర alternator highly stable లో ఉంటుంది. Okay, next. The reluctance torque of salient pole alternator is maximum at an angle of dash. Reluctance torque. So మనం salient pole alternator లో 2 powers ఉన్నాయి, electromagnetic power and reluctance power. Reluctance torque అనేది proportional to reluctance power. Whenever reluctance power is maximum, automatically torque కూడా maximum. చెప్పండి, already we discussed this point. Reluctance power అనేది maximum at which angle, at which load angle? Reluctance power proportional to sin 2 delta. Sin 2 delta. Whenever delta equal to 45 degrees, reluctance power is maximum. Whenever it is maximum, torque also maximum. So at load angle 45 degrees, it is maximum. Okay. Next question. An alternator having, you try to tell answer for this. An alternator having excitation voltage of 1.414 per unit and synchronous reactance of 2 per unit, supplying half rated power to the bus bar at rated voltage, then load angle is dash. Question very easy, just power equation. Alternator having excitation voltage given, synchronous reactance given, cylindrical pole alternator it is, supplying half rated power to bus bar at rated voltage, rated in per unit 1 per unit. Find out the load angle. Find out load angle here. Answer. Yes. What is the power equation of cylindrical pole? EV by XS sine delta. RA not given means neglected. EV by X sine delta directly. How much power it is supplying here? How much power it is supplying? Half rated power. Half means 0.5 equal to excitation voltage nothing but EMF 1.414 is nothing but root 2. At rated voltage nothing but rated voltage bus bar voltage or rated voltage is 1 per unit. Synchronous reactance given 2 per unit. Then only unknown is sine delta here. Then if you simplify sine delta we get 1 by root 2. Then what is delta? 45 degrees. No? The load angle is 45 degrees here. Okay. The load angle is 45 degrees. So these are some model of questions for today because time is very less. That's why we taken very few questions taken. So anyhow, before attending exam, you should go through the complete notes, whatever you have with you, all the points once. So don't leave any point because we cannot guess where we get exactly. Only some important we can guess from there, but not 100% guarantee there. So there is so much time still. So whatever time is available this 15 days, try to prepare well and try to practice well, but don't mug up the questions and answers. Most of the students will do this. They will by the question answer by looking at previous backside bits of so many textbooks and materials. Don't do that. Try to learn a small subject, try to learn subject, and you can answer any type of question, whatever the variation they given in the question. But with by hearting so many bits and options, you cannot answer, definitely it is. Okay, so all the best.